Hi folks, so in this video what we're going to do is complete a question here based on the topic of perspective, and it's based on drawing this little structure here, so it is. Okay, so this question here itself actually comes from the, I think it's Graphics in Design Communication textbook for the Leaving Cert. I'm sure I have that right. Yeah, Graphics in Design and Communication textbook, and that's based on, as I said, perspective. Okay, so what we're given here is the elevation of a structure, and we're given the plan view of the structure, and all we're told is a little bit of information around the scale, the ground line to the height line, and so on as the measurement there of 9 meters, and we're given the elevation plan with the various measurements. Now, in regards to the scale, we're going to apply the scale to the measurements to be able to fit it on our sheet. I can see that the overall length of this side here, the face here, is 20 meters. Now, if we work scale, 20 meters equates to 20,000 millimeters. And what I do is I take the measurements of 1:200, and I would divide the 200 into that. And essentially what that means then is if I get rid of the 0, 0, 0 and 0, 2 on top, 2 on bottom, 200 divided by 2, that will become 100. Therefore, 20 meters equates to 100 millimeters. 8 meters would work out to be 40, 10 meters would work out to be 50, and 2 meters would work out to be 10. The 9 meters here will work out to be 45, the 5 meters is 25, and the 4 meters is 20. And then in regards to heights, I've got 25 here, 50 for the 10, and 75 for the 15 meters. So there's our various heights. So I can see that on the structure, the height of this kind of platform here, this face, is 25. The height of this little face here, okay, or of the sloping surface, is 50, and the overall height of it is 75. Now, as always with perspective drawing, we draw the plan view first. And I've done mine in portrait and I've positioned it up here. And what they tell us is that the picture plane touches corner A. So, next thing is, from corner A, what is the distance to our spectator? It's a vertical line down at a distance of 18 meters. That will work out to be 90 millimeters away. So, that's step number 1. From corner A, we want to do a vertical line down, and we're going to measure a distance of 9 meters. And we'll go down like that, and we'll go 9 meters down. Now, that's my spectator. Now, the methods completed are, from the spectator, you want to create what's known as your cone of vision. So this is the person, that's the furthest left of the object they see, and the furthest right of the object they see. That creates what's known as our cone of vision. Then we need to get the line of sight, which is right in the middle of the cone of vision, and the only way to do that is bisect the angle. So bisect the angle created by your cone of vision. When you get that line is called the line of sight. So we've bisected the angle there. And from the spectator, I'm going to draw a line through that. What I often like to do here now is set up my picture plane perpendicular to the line of sight. Our picture plane is touching corner A, but our picture plane is always perpendicular to the line of sight. So I've drawn my line of sight. Now I'm going to rotate my set square so I'm perpendicular to it. Through corner A. And there we go. So there is my picture plane. Now what I often like to do here is just extend it so. And usually we write PP to identify the picture plane. So there's our picture plane. Now, for demonstration purposes, I will put in my line of sight in yellow, just so we can see it. That's my line of sight. And now what I'm going to do is I'm going to set up for my vanishing points. Now, for the vanishing points, if I look here at the drawing, the vanishing points are going to be dictated by the direction of the faces. I can see that the faces are going 30 degrees in this direction, and they're going to be going 60 down here. Why is it 60? Well, the reason it's 60 is because that angle is 90 degrees. It's a perpendicular angle. Therefore, 30 is here, with 90 in here, and if I continue the straight line out, the angle that would be left in here is 60. Okay? So that's the direction of my faces. So that's going to dictate now my vanishing points. So, any faces that are going parallel with these lines, where my pencil is, I'm going to go at 30 degrees. So from the spectator, over 30 degrees like that, and then any faces that are going in this direction are going to go at 60 degrees. And there we go. So I've got my 30 degrees and my 60 degrees. And what I often like to do here is, again, just using our highlighter, recognizing the lines that are going to be used for my vanishing points. Next job now, to make our lives a bit easier so that we don't have to do sliding set squares, we're going to untape our sheet and we're going to retape it down so that the T-square is in line with the picture plane. My T-square right now would not be in line with the picture plane. Just going to take off the tape. I'm going to rotate my sheet just slightly so that my T-square will now go in line with it. And what this does is it eliminates the fact of using sliding set squares. So rotate the sheet. There we go. Take this guy. Get my masking tape. Take this. I'll tape down here. Okay. Now the next rule is go back to the sheet. What is the distance from my ground line to my horizon line? It's 9 meters. That 9 meters will work out to be 45. So the ground line up to the horizon line is 45 millimeters. So the ground line can go in anywhere. So zoom out here. Bring this a little bit closer so we can see it there. So from the spectator, I'm going to come down about to here. I'm going to set up my ground line here. Now, in regards to the ground line, it can go anywhere, but I always like to be able to keep my horizon line below the spectator as much as I can. And I know above the ground line it's 45 millimeters up to the horizon line. Horizon line is a horizontal line like that, parallel with the ground line and picture plane, but then these guys here that I brought over that were parallel with the faces, they're going to help me locate my vanishing point. Where it hits the picture plane, I'm going to drop it down vertical, or perpendicular I should say. And there we go. And that's going to help us locate VP1 and VP2. And there we go. That's our setup. Now, this object kind of comes in 4 little blocks, okay? So I'm going to actually colour them in. The first one I'm going to do is this little guy here. So I'm going to build this little block here first. And while I build it, I'm going to imagine that this little tower element is not there. Imagine if that tower was not there, so it wasn't here in plan, it's like it would continue on to here if the tower wasn't there. Okay, so what's the height of this? That's where corner A is. The height of that edge is 25 and the height of this edge here is 50. And because corner A touches the picture plane, I can treat corner A as a true height. I can measure up 50 and find this point here at the back as well. So that's the first little element that we're going to do. We're going to build it up in little blocks. So from corner A, I'm going to bring it down parallel with the line of sight. In this case it's just going vertically down or perpendicular to the picture plane. I'm going to locate corner A down here. And because corner A is touching the picture plane, it's also going to touch the ground. I'm going to measure up those heights of 25 and 50. Now, what am I going to do now? As I told you, I want to imagine if this tower block was not there. So if it wasn't there, technically, this line here would continue on up as far as there. So I want to find this object, as I said. Well, we have corner A and we know it goes up as far as here. That's the edge as far as the 25. I'll actually heavy it in. There we go. But this face is going off in this direction. Because the face is going in that direction, it's going parallel with this line. That means I have to vanish that face over as far as VP1. Now, the face is going to go over here, and it's actually the 50 that I'm going to use. I don't need the 25 for this side. It's this one, the face is going in this direction. It's going to go parallel with that, which means it vanishes over to VP2. The base one is going to vanish over, and the 25 is going to vanish over. Now it's a case of finding where they end. Well, this is the face or the object that I'm focused on first, this little block. It ends right here. We bring it down to our spectator to get the spectator's view of it, and then where it hits the picture plane, we drop it down. And there we go. And now, where that 50 vanishes back, that will show me where the 50 is at this height back here. And there we go. Now that I've that done, what I'm going to do is I'm going to build the object. So I want to find where it finishes here. As I said, imagine the tower was not there. I'm going to bring it down to my spectator, stop it at the pitch plane, and the other point I want to find is this one. Bring it down to the spectator, stop it at the pitch plane. So this guy is going to come down, it's going to be down there somewhere, and this one is going to come down. So the one I want to find is the one on the top. The roof is going in this direction, the slanted surface. That little line there that I'm on about, that one there is going in this direction of my pencil, so that means I have to use this line, which is VP2. So for the top of the roof, I'm going to bring it across, and you'll see then when this guy came down and follow it down, it actually hits right there, and I know then I can connect it up here like this, and there we go. So that is part of my structure done. I'm pretty sure I can see all that as well. So heavy in that. Now, I won't heavy all this going down here. The reason being is because even though I've drawn in that kind of object, I do know there's a tower to go in there, okay? And because there's a tower to go in there, I can find this edge, okay? So if I bring this guy down to my spectator, stop it at the pitch plane, what I can do is I can find this edge right here. As I said, we'll imagine it for the moment as if the tower wasn't there, but I have put in the edge of where the tower would come to. In reality, I'm saying that it goes as far as here, but then the tower gets in the way. So that's that little block there. Essentially what I've done here is this. If I go over this with my pen, I'm after doing this line. I've done all of that. I've done this. I haven't put in this. I've done this and this. Okay, but in reality, as I said, if the tower wasn't there, it would kind of go down like that. That's kind of what it would continue on to, if the tower wasn't there. Now the next thing I'm actually going to focus on is this little block here at the back. I can find that face, then I can find this face, and I know there's a triangular prism at the edge of it, but it goes all the way over as far as there, and I can get all of that. That's the next bit I'm going to focus on. So, to get that next bit, what I want to do is I'm going to bring the points down. Well, this one is already brought down, it hits here. Here's the other point I need, bring it down to your spectator. And the other one that I need is this one back here, because that's where it ends. Even though the triangular prism is here, that's the plan view of it. I'll bring it down to the spectator, stop it at the pitch plane. It's kind of hitting right there, close to A. Now, what I want to do though, is I want to find these points here. And the problem I'm faced with here is, this height here is at a height of 75, this one back here is at a height of 50. If I get the sheet, you can see the one at the top is 75, this one here is 50. So, the problem is they're not touching the picture plane, unlike A was earlier, and A was connected to this face and this face. So what can I do? I can use a height line. Now, there's different ways you could do height lines. You could bring the height lines down like this, and then this one like this. But that's two separate height lines for a height of 75 and 50. If I'm clever, I could just extend the face this way. I'm kind of going into the drawing now. Put it in nice and heavy so we can see it. I'm going to call that X. So, like A, it's all I've done. It's like I've taken the face and I've extended it forward, okay, until it hits the pitch plane, like corner A. When it touches the pitch plane, I can treat it as a true height. So X is now down here. And the height of those surfaces are 75 and 50. So from X, I'm going to measure up heights of 50 and 75. And what I have to think of now though is, I'm after taking the line in this direction. So which vanishing point do I want to do? So parallel, the line was going in this direction, the height line. It's parallel with this guy, which means I have to use VP1. So the 51 will vanish back to VP1, and the 75 will also vanish back. Excuse me. Will also vanish back as far as VP1. Somewhere along this line here is going to be my 75 height. Somewhere along this line here is going to be my 50 height. This is the one where the 50 is. So where it hits the picture plane, let's bring it down. The 75 one, let's bring it down. And we'll build up that face. What I've found now is the 75 height and the 50 height. And I can draw them in. So there's the 75 and the 50. Now the question is, how far do they come down? Okay, that's the question. But because x is also a height line, technically I could vanish x from here, and that will show how far they go down because x is also on the ground. The other way I could have done it was using this point here. So just to show you, this will be the face. I'll bring it down as far as that x line. So x is also on the ground. What we found is the face. And what's so helpful about perspective is once you have the face, you can kind of complete the object. Now, the other way I could have found this point here was from VP2 I could have vanished through this point, and I should also go through it. And there we go. Tiny bit of inaccuracy for me there. But there we go. Okay, and that's another way I could have found it. Now what I want to do is I want to complete the rest of the structure. I know it goes back as far as here, which comes down to here, so it comes down as far as there, so I'm going to drop the line down, and somewhere along that line is going to be a point. Here's the top of the roof. The roof is going in this direction, which is parallel with this guy, which means I'll vanish to VP2. And there we go. And now I've got that. Now, that's the top of the roof. The other points I want to find on the roof, and I'm going to start building the triangular structure now, is the triangular prism. I've got this guy and this guy. Now, when I'm doing the triangular prism, just come in here, I want to find the top 2 points, there and there, and I know they connect down to the bottom 2 points, because in reality, that little triangular structure is kind of going down like that there. If the tower wasn't there, it's going to be quite hidden now behind the tower, but we will still put it in for reference. So, to find it, I just essentially need to find 4 points. This one and this one are on the top edge, which we have. I already have the one at the very end. How would I find this one? Well, I know it's along this line, so if I follow it down, bring it down, it's right there. So I'll just put little dots in them, so I know where they are. Okay, so I found those 2 points. Now I want to find the 2 points that are going to be down here somewhere. Well, one is here, so it's the spectator's view of it, when it hits the pitch plane, so right there, and the other one is right here. And there's that one. Now, there's a couple of ways you can go about this. You can either use a height line. I could bring a height line down and find it, or a height line out here and find it. But what's actually quite helpful here is I do have a point in here already. That little point I'm referencing there. That's quite helpful. So what I'm going to do is I'm actually going to extend, because I have that point there, down here, I'm going to extend out the face here and find the bottom part of the tower. So, I'm going to extend out that. And if we look at that line, it's going in this direction, which is parallel with this line, which means that I have to use VP1. So from VP1 through this point, somewhere out along there is going to be where the tower is. How do I find the point? Well, it's just a spectator's view of it. Bring it down to the picture plane, and we'll drop it down. And now I know roughly where the tower is going to be going. So I've got that. That's the bit of the tower that juts out. So what's helpful about that now is, because I have the edge here, I can now do this, which is where the triangular prism is, and I'll be able to find this point and this point. That line is going in this direction, which is parallel with this guy, which means I'm going to go to VP2. So somewhere along that line there is going to be this point and this point. I have them here, so now it's just simply a case of dropping them down. There's that one, and that one. So now that I have those, there's that one, there's that one. This is actually where the tower is going to be going, so I'm going to heavy in a little bit of the tower now. It's like I'm doing part of it with the triangular prism. That's kind of the tower bit I'm putting in there. But I know this point then will connect up to that one. So I'll just put it in lightly, just for reference. And then this one connected up there as well. And I can kind of put in the triangular bit at the end. And there we go. So that's the little slanted surface, but now it's a case of finding out about the tower height. So, what height is the tower? If we come into our drawing, I can see that the overall height of the tower, it goes as tall as the whole drawing, so it's a height of 75. So to do that now, what I would have to do here is I would actually have to use a height line. Now, I'm going to do a height line. I'm just thinking here, you can bring it out here. I'm actually going to bring it out this way. So if I extend that face there, just do a bit of sliding set squares here just to make sure I'm accurate. That line is quite short. Let's go parallel with that line. Just sliding set squares. It's another height line. Okay. Last one was called X, so I'll call this one Y. Okay. So now that I've got a height line, I'm going to bring Y down and find Y, kind of like A. What's the height of the tower? The tower has a height of 75. It's going to measure up 75. There's my 75 right there. Now the question is, which vanishing point does that go to? If you look at the height line, I did this one here. It's not parallel with this line, so it can't be VP2. It's parallel with this line, so it has to vanish over as far as VP1. So if I vanish that all the way over as far as VP1, somewhere along that line that I've just done is this point. Okay, because that's the one that I did. And it will also be this one, but I'll just find this one first. Follow it down. Follow it down. You have to be super careful here. There we go. That's my point. So that's how far I go up as. There we go. I've kind of got that part of the tower. Now I'm going to get the front face. The face is going in this direction. Quite easy. Just go across here. There we go. So I've got the front face of the tower. Let's get that in a little bit better. So there's the front face of the tower. Okay. Now I want to build the back face. So how do I find the end here? I'm going to bring this across, or sorry, down to my spectator. That's where this face ends. As it goes back here, it'll hit right here on the picture plane. So I'll drop it down. And then that face we've already seen is going across here. So we've actually got that now. And what's helpful here then is bring this down. Problem is I don't know exactly how far it's going just yet, but what is nice here is I can actually start to heavy in certain details of the triangular prism now at the back. And there we go, and we can start to see it taking shape. The last bit I'm missing is the little bit that's going to be going down here. Okay, now some people might assume it's just parallel. It's not. There's a couple of ways you could do it. Okay, you could find this point here, which is on the slanted surface, okay, and then vanish it across. That's probably the easiest way. So if you have the slanted surface of the triangular prism, because it touches the edge of the tower, so it'll be touching somewhere along there, more than likely right here, I'd imagine, and we would vanish it across. So that's one way we could do it. I'll show you a second way. So I can bring this down. You can see that point there, it's on the slanted surface. It's even on the slanted surface of the roof. Where it hits there, I'm going to bring it down. Actually, it's a little bit out. And there it is. And we'll see that point that I've just found there. Okay, you can see it inside there. The line is going in this direction. Which vanishing point is it parallel with? It's parallel with this one, which is VP2. So from the VP2, I would vanish through it. And then that will show me how far this goes down. And I can find that, and I know then that this guy connects up to it. So there we go. That's one way I could have done it. I will show you another way. What's good about this topic is there's lots of different ways of figuring out the solution. So that's one way. The other way I could have done it was this, because I had this point right here. That point there is this point, which is here. Okay. I could have extended the line up. Because I have the line, I'll just follow it up. And found a point at the top, which would be somewhere along this line. So that's the way I'd often usually do it. I'd bring that down to my spectator, stop it at the picture plane, bring it down until it hits the edge. It would hit the edge right here, and it's just like a line that goes down along the roof. I could simply have joined this point then to that, and you'll see they meet up as well. So that was another way I could have done it, by finding a point on the top part of the roof and bringing it down. Okay, so you have it, folks. That there is a perspective question. Nice little challenging problem where we had to use height lines to help us determine sloping surfaces. At higher level, the only difference is that you would be getting a slope surface by using what's known as an auxiliary vanishing point, which actually sometimes is a little bit easier than using those things. Okay, so you have it, folks. I hope you found that helpful. That's the video done.